Let's do one more example on finding derivative of the function that involves logarithms and chain rule and square roots. Okay, step 1. Let's rewrite the function we are working with. If I see a fifth power root, I would like to rewrite it as natural log of 10 minus x squared, everything raised to the 1/5. 1/5. Then this is a new function now I'm working with. Step 1. And I think now it's more straightforward how to differentiate it. So now, based on the chain rule, I see that there is some kind of function raised to the 1/5 power. That means we're going to use a power rule. 1/5 goes down, copying the whole function, don't change it, and change the exponent. 1/5 minus 5/5 will be -4/5. Chain rule says now multiply by a derivative of the function inside, and the function inside, I will use a different color here. I see now it's log of something. Log of something tells me that derivative will be 1 over that something, 10 minus x squared. Now chain rule says you can look even deeper inside and multiply by the derivative of the function inside. I see 10 minus x squared inside, so multiply by the derivative of 10 minus x squared. I'll put it here in the numerator. That is -2x. Not too bad. Now they ask us to actually evaluate this derivative, which I just found. Here it is. At the given x. Step 3. At x equals 1, y prime becomes 1/5 ln 10 minus 1 squared is 10 minus 1, which is 9. Everything raised to the -4/5 times -2. 10 minus 1 is 9. Now, I will just use a calculator. I know how to collect the constants around, so it's going to be these guys over here. So it's going to be -2 over 45. But when it comes to the log of 9, I would prefer to use calculator to make life easier. So it's going to be approximately -0.0236765. If you are working with online homework, we always recommend to input as many decimals as you can see in your calculator to make sure that the program accepts the answer. I personally like the exact answer over here because that one is a very good solution. So you choose whether you want to type the exact answer or to give the approximate answer. That's all. Thank you.